Welcome to today's Science Short. In this short, we're going to be talking about aerodynamic forces and how something called lift can interact with big machines to do incredible things. First, let's define aerodynamics. Aerodynamics is anything that has to do with the movement of air around objects and how the air interacts with these objects. Aero, meaning air, dynamic, meaning moving, aerodynamic. So, aerodynamic forces are the forces in the air that cause things to move. What about force?
A force is a push or pull on an object. It can make an object move, change its speed, or even change shape. Gravity is probably the most well-known force. The force of gravity pulls us down towards the Earth. Its direction is towards the center of the Earth, so it wants to pull us down there. In today's Science Short, we're specifically talking about aerodynamic forces. Remember, aerodynamic forces are related specifically to the movement of things through air or some other fluid. There are four main types of aerodynamic forces: drag, thrust, weight, and lift. Each of these arrows represent one of the four forces. This one is drag, and this one is thrust. These forces work in complete opposite directions. If the thrust force is bigger than the drag force, the airplane moves forward like this. Weight and lift work in opposite directions just like thrust and drag, but in the up and down direction. This is the weight force, and this is the lift force. If the lift force is bigger than the weight force, your airplane can then lift up and fly off the ground. So how can we make it so that the lift force is bigger than the weight force? Well, there are a couple of different ways to do this, but let's look at an airplane wing. See how the wing has this little bump and tapers off towards the end? The wind has the option to either move over the wing or move under the wing, because it can't go through it. The wings are designed to cause more of the air to go below it rather than above. The air above the wing has a further distance to travel because of this little bump right here. So it's got to move a little bit faster to catch up with the air that's going under the wing. Because of these speed differences, there becomes a pressure difference as well. The pressure under the wing goes up while the pressure above the wing goes down. And having a higher pressure underneath the wing makes the lift force increase, and the lift force is then greater than the weight force. That makes the wings go up. This principle can also be applied to wind turbines, like the ones we install here at One Energy. Let's go take a look in the yard at a wind turbine blade.
This is a wind turbine blade. It looks pretty similar to an airplane wing, with the bump on the one side that tapers off towards the end. When installed, wind flows towards the front of the blade, and because of this bump on the one side, the air goes over that side, has to speed up to catch up with the air going under. These speed differences create pressure differences above and below the blade. These differences is what creates lift, and this is what pushes the blades to move. When someone says wind turbines blades are designed to specifically catch the wind, they're just designed to create lift so that these blades can start spinning and making energy. Lift causes these three turbine blades to rotate. The spinning rotor is connected to the generator, which in turn produces electricity. Power can be used to turn on a light bulb or run an assembly line. The only thing making these blades move is the wind, and how the wind interacts with these blades, and the lift that is created because of that interaction. Aerodynamics and the force of lift makes wind turbines spin. Just like that one. Thank you for tuning in to One Energy's Science Short about aerodynamics and lift. See you for the next one, and remember, challenge everything.